chi-square is a non-parametric test, which can be used as a test of difference with an independent measures design, or it can also be used to analyse correlations which generate nominal data. The example we're going to look at is Piaget's very famous conservation experiment. Our experimental hypothesis would be 7-year-olds will be more likely to be able to conserve than 5-year-olds. This is a directional hypothesis, one-tailed, as we are stating which group will be better able to conserve than the other. The first step is to enter our data into a contingency table and calculate the degrees of freedom. Degrees of freedom simply means the number of cells which are free to vary. The calculation for degrees of freedom is the number of rows minus 1 times the number of columns minus 1 in your contingency table. In this case, there are 2 rows and 2 columns of data. Therefore, 2 minus 1 times 2 minus 1 equals 1. So degree of freedom in this case is simply 1. You can see the formula for chi-square on screen. It's a formula that looks complicated but really isn't once you break it down. The little symbol you can see with the squared next to it, which looks like a bit of a curly X, simply stands for chi-square. O in this case stands for observed values, that's the data you've collected, and E stands for expected values, the data you would expect to find if your findings were to support your hypotheses. The first step in the calculation is to calculate your expected values from your contingency table. The formula for this is row total times column total divided by grand total, and we do this for each cell. So if we look at the first cell, 5-year-olds able to conserve, for this the row total is 20, the column total is 25 and the grand total is 40. So 20 times 25 divided by 40 equals 12.5. Once our expected values are calculated, the data can then be entered into a table to calculate chi-square. The next stage is to calculate observed minus expected. 8 take away 12.5 is minus 4.5, and so on. The next stage is to work out the value of O minus E squared. Minus 4.5 times minus 4.5 is 20.25. 4.5 times 4.5 is 20.25, and so on. The next column is to calculate O minus E squared divided by E. 20.25 divided by 12.5 is 1.62. And again, we complete this calculation for all 4 cells. The final part of our calculation is to add up these values. Once we've added them up, we get a calculated value of 8.64, and that is our chi-square statistic. We now need to discover if this result is statistically significant, and to do this we need to consult the critical value tables. Remember, we're doing a one-tailed test and we've already calculated our degrees of freedom as 1. In chi-square, the calculated value must be greater than or equal to the critical value in order to be significant. The critical value is 2.706. Therefore, our results are significant. We can reject the null hypothesis as evidence has been discovered to support the hypothesis that 7-year-olds are much more likely to be able to conserve than 5-year-olds.